Hi. In last video we have seen the basic working principle of any counter. So in last video we have explained 2-bit counter, so how it is going to perform the counting function, and also we have also seen some important points regarding counter, how their frequency function is going to be dependent. So that is, if you are having n number of flip-flops which were placed side by side, so what will be the frequency of the last flip-flop? So it is nothing but the clock pulse divided by, so the frequency of the first flip-flop clock pulse, so divided by how many number of flip-flops are there from starting to the end. So we will divide by that number, so that will give the frequency of the last flip-flop. Okay, so frequency of the output of the last flip-flop. So that is why flip-flop is going to be termed to be as frequency divider circuit. Okay, so therefore, and we have also seen how it is going to count the numbers. Okay, so that is nothing but, so if you are having a two clock pulses, sorry, two flip-flops, if you are having two flip-flops, okay, so we are going to have how many number of events that can be count. So it can count, that is 0, 1, 2 and 3. So therefore 4 events it can count, and the decimal number, the last decimal number that can count is given as 4 minus 1, that is equal to, so 3 is the decimal number, but it can count 4. So that means we have taken a 2-bit counter. So it is, I have told that as a 2-bit because you have got a two binary bits, sorry, two states. So that is for QB and QA with that 0 0 0 1 1 0 as well as 1 and 1. So total you have 4 states. So 2-bit counter will have 4 states, so that these states are nothing but your counting. Okay, now so this is the way how any counter is going to be worked out. Okay, so also we have seen about a synchronous counter. Okay, so what do you mean by synchronous counter? Because it is if they are having a different clock pulses of sources, different clocks sources. For first flip-flop we are going to give the clock pulse, and for the second flip-flop the first output is going to be given as the clock, and similarly up to so on, how many number of clock pulses are there, we are going to proceed in the same way. So just like as we have seen in case of 2-bit counter, as it counts from 0 to 3. Now I'm going to draw that picture, that is a 3-bit counter. Okay, so in the same video I'm going to explain one more concept, so then I will tell later. So a 3-bit counter, what it does, so it will count from 0 to how many, 7. So that is total number of events are 8, but so what will be the largest number that it is having? It is nothing but the 7. So here what is the counting? So counting can be done either we will start with the ascending order or a descending order. That means we will start with 0, next 1 2 3 4 up to so on n. So this is called as what? This is nothing but a up counter. We are going to call it as up counter. So that means the number is going to be increased one by one. So next coming to down counter, that means we will go with n, next n minus 1, next n minus 2. So likewise up to 3 2 1 and up to so on 0. So this is called as down counter. Okay, so down counter, so the counter which starts from 0 and it goes on n, so that is called as a up counter. So the counter which starts with n and goes towards 0, so that is nothing but what? A down counter. So with the slight modifications for up counter, so we can have a down counter. So okay, I will also show how to what are the modifications that has to be done for up counter to get a down counter. It's very easy concept, don't worry about that. If you know clearly about up counter, so previously what we have seen a 2-bit counter. Okay, so a 2-bit counter which is counting 0 to 3, since obviously it is termed to be as what? Up counter. Already we have seen, but I have not given this terminology before, but it is also a up counter. Okay, so now we are going to see about a 3-bit counter. So once a 3-bit up counter, once we know once you know how it is working, okay, so next we will draw the 3-bit down counter. Okay, so that is about this video session. So if you see here, if you want to count from 0, 1, 2, 3, 4, 5, 6, 7, and if you want to stop it here, okay, so that means, so here you are going to have so total 8 events, or whatever it may be, 8 states or events. So this is the thing. So since you require 8, so obviously the 7 has to be, we need to indicate that event. So for indicating that event, as previous we have taken QA, QB, and we will have one more thing, that is QC, so that the values 0, 0 to what, so you will have up to triple 1. Okay, so therefore how many counters we require? Obviously we require 3 flip-flops to implement a 3-bit up counter. Okay, so 3-bit up counter. Why I am telling this is an up counter? Because it is, we are going to start with 0 and we are going to end with towards 7. Okay, so now we are going to design so with a 3-bit up counter. So therefore we require so 3 flip-flops which are to be connected as we have seen already in case of previous lecture. So now I am going to draw that diagram. Okay, so you also, if you are watching the video, so along by looking at the video, if you draw the circuit, so that will be very helpful for you, while because no need of by hearting the things. So by hearting the things will not make any sense. Okay, so this is your first flip-flop, and since we require 3, so therefore I am drawing 3 flip-flops. So this is our third flip-flop. Okay, so this is your third flip-flop. So for the first flip-flop, it is JA and KA, as well as we require QA. So JB and KB, as well as you require QB. So JC and KC, we will take the output from QC. So for the first clock pulse, okay, so it is a negative edge triggered. So negative edge trigger, every clock pulse is negative edge triggered. Why? Means because to get rid of race around condition and get the toggling state. So for the first flip-flop of A, so if this is B and this is C, so okay, so the first clock pulse will be given to the first flip-flop or A flip-flop number A. And we know that as we have drawn in previous, for J is equal to 1 and what, so K is equal to 1, so our flip-flop will be in toggling state. So to give that toggling action, so as we have seen that previous, because of the toggling action only, okay, so the counting is possible. So therefore what we give, so we have to give so the logic 1 for every flip-flop. Okay, so this is for J as well as for K. So next J as well as for K, next for J as well as for K. So these are the inputs that we have given. Next, what about the clock pulse for second flip-flop? So that will come from the output of first flip-flop, as we have seen in previous. So similarly, what about the third flip-flop? It will come from the second flip-flop, output of second flip-flop, and given as negative edge triggering. Next QC. Okay, so next QC, this is our last flip-flop. So this is our first flip-flop, and this is one more flip-flop of your required output. So I want some space because we need to draw the clock diagram. Okay, so therefore, so this is what, so QC, which will act as what, MSB, and this is QA, where it will be LSB, and in between middle bit, that is QB. So this is the 3-bit up counter logic diagram. Okay, so if you represent the complemented values also represent or may not represent, no problem about that. But here you have to write that what is the input we give, that is equal to what, logic 1. Okay, so this is the logic 1. So now we will see how it is going to count the events. So we know that for the first clock pulse we have to give from outer source. Okay, so that one I will draw as we have drawn previously. Okay, so we'll check down. So this is, here I have taken the clock pulses. So this which is given as the output, which is given as the input for this first flip flop. Okay, so this is the free. Okay, so this is the thing. So next, because of this clock pulse, what, so we have given as negative edges. So we will represent all the negative edges. So this is one negative edge, negative edge, negative edges. For each negative edge, the input for the flip flop is going to change its input. Okay, so it is going to change its input. Now so here next we have to estimate what, so we have to estimate 3 outputs. That is, first one we will draw for QA. Okay, so QA, let's assume as we have done before. Okay, so we are assuming that the previous state of QA is nothing but it is being in QA is equal to 0. We are assuming for present value for QA is equal to 0. If QA is equal to 0, okay, so unless until you have negative edge triggering at this up to this point, okay, so up to this point whatever the previous state it is there, it is going to be present as it is. Okay, so once you have, or if it is receiving a negative edge, the clock is received, sorry, the flip flop is receiving a clock of negative edge, then it will look for the values of j and k. Since already we know that for the values of j and k is equal to 1, so whatever the previous state is there, so it is going to be complemented. Okay, so therefore up to negative value, up to negative edge triggering, sorry, up to a negative edge point. Okay, so this is the point, up to here you are going to have a previous state of 0. So whenever it is having a negative pulse, then it is going to see the inputs for j is equal to 1 and k is equal to 1, j is equal to 1 and k is equal to 1. So our state is nothing but what, so qn becomes what, qn complement. Now what is the value of qn here, qn is 0 and its complement is nothing but 1, so therefore it will be up to a negative edge. So again, once if it is sensed with a negative edge, again it looks for inputs. The inputs are not being changed, the inputs are set for always 1. Okay, so therefore since it is always 1, j is equal to 1, k is equal to 1, whatever the value it is there, it is going to be complemented for the next state. So next it is going to have 0 up to the next negative edge point. So likewise it is going to repeat what, the cycle up to, for every negative edge it is going to change its input. If the input, since but here input is being constant for values of j is equal to 1 and k is equal to 1, just it is going to produce the complemented value of our previous output. Okay, so next what we have to say, this next we have to look for qb. So for qb to get its output, okay, so don't think that so whenever you give clock pulse here and j and logic is equal to 1, all the what, so all the flip flops will give their outputs at a time. Okay, so please don't think like that, because it's since unless until we give clock pulse to this input, it will not work, because from this you have to get the input. Okay, so unless until we have the output here at qa, you will not get input for clock b. So unless until you get clock b, clock input for b flip flop, you will not get output at qb. And if you don't get qb output, similarly, so here clock pulse will not be available. If this clock pulse is not available, obviously qc will also not available. So therefore there will be some time lagging process, but not much. But definitely when whenever you give clock pulse here, you don't, but please don't think that we will give directly qa, qb and qc, because after giving clock with respect to ja and ka, qa will come. After coming qa, so this clock will go to this b flip flop, then with respect to jb and kb, qb will come. After qb coming, so with respect to this clock, again it will look for jc and kc, again the qc will come. Okay, so likewise, so therefore, so now, so we have qa, so qa will act as clock pulse for second flip flop. So therefore again it is negative edge triggering, so therefore it will look for what, negative pulses. So up to negative edge it will be in previous state. Once it is receiving a negative pulse, so it will present toggling, so therefore again it will be in likewise it is going to present it output. So this is for what, this is for qb. Next, what about qc? So this is for qc. So qc will look for negative edges of what, qb. So unless until qb is positive, so here it will change. So therefore again you have here. So this is all about what, so the pulse diagrams. Okay, so likewise, so you try to draw lines with your scale. So since it takes some time, so therefore I have not drawn here. Okay, so here if you see, if you observe just a frequency, say what will be the frequency? So here it is the frequency of what, tc. Okay, so this is tc up to here, so tc. So next, what about this? This is the frequency, I mean time period of ta. So this is the time period for what, tb. So this is the time period for what, so tc, I mean qc, since we have taken, I'm telling it as qc dash. Okay, so because tc and tc are becoming same. So next, okay, so then what value, so what is the value of ta here? So ta is equal to 2 times that of tc. Next, what about tb? tb is equal to 2 times that of ta. Next, what about tc dash? That is equal to 2 times that of what, 2. So tb, so if you substitute here, what will be the value? So you just replace everywhere, so you will get 8 times that of tc. Therefore fc dash will become what, fc divided by 8. Okay, so the frequency of the last flip flop, so fc dash. Okay, so the frequency of last flip flop is being divided by what, so divided by 2 cube, that is nothing but 2 power 3, where 3 is nothing but what, number of flip flop. So likewise we can have this frequency. Okay, so you please take down this on side of your notes, or you continue in the notes. I am going to rub it now. Okay, so this is, so here now we will see how it is going to count. Okay, so how many clock pulses are there? So how many we have taken? We have taken total 8. So therefore 1 2 3 4 5 6 7 and 8. Okay, so this is our clock. So now we will see for first clock time period. So this is up to first time clock period. The value of qa is what, 0. The value of qb is also 0. The value of qc is also what, 0. Therefore what, 0 0 0. So first 0 represents, so lsb, this is qa, this is qb, and this is qc. Okay, so next, for second clock pulse, so the value of qa is equal to 1, so the value of qb is equal to 0, the value of qc is also 0. So therefore 0 0 1. Next, for the third clock pulse, what is the value of, so this is 0, so this is 1, so this is 0 0 1 0. So next, for fourth clock pulse, the value is 1, so this is 1, and for qc the value is 0, so therefore 0 1 1. Okay, so for fifth clock pulse the value is 0, the value of qb is 0, the value of qc is what, 1. So therefore 1 0 0. So next, for sixth clock pulse, the value of QA is what? 1. The value of QB is 0. The value of QC is 1. Okay, so therefore 1 0 1. So next, for seventh clock pulse, the value of QA is 0. The value of QB is 1. The value of QC is 1. Therefore 1 1 0. And okay, next, this is the last pulse. So for this, so this is 1 1 and 1. So the value is 1 1 1. Okay, so if you want, so you see here, after that, so every value is becoming what? 0. So here you have 0, here also you have 0. So if this is nothing but what, so which one belongs to? So this belongs to ninth clock pulse. If you write for 9, this is 0 0 0. So therefore a 3 bit, so up to here you have the event. So after here it is what? It is a repeating. Okay, repeating again from 0 0 0. So therefore how many? So 1 2, how many events it has calculated? It has counted 8 events, or 8 total. How many states? 8 states. Okay, so how many numbers it is going to count? From 0 1 2 3 4 5 6 and 7. That is nothing but 8 minus 1, you will have up to 7. Okay, so this is all about what? So 3 bit up counter. Why? Means because it is going to start with 0 and it is going to end with what? 7. After 7 again it is going to repeat with 0, and again it is going to stop with 7, and again it is going to repeat with 0. Likewise it will proceed unless until you give for logic is equal to 1. Okay, so this is all about your asynchronous 3 bit up counter. So now for down counter, what we have to do? Okay, for down counter I will draw the picture here, but so he, okay, so here, as I have explained here, so the pulses will just reverse. Okay, so previously, but first I will draw the circuit diagram. Okay, so that it will become very easy. So here this is up counter. So now I am going to draw the down counter. Okay, so for this is JA. Okay, so KA and QA bar. Next JB, KB, so QB bar. Next JC, KC, QC bar. Okay, so here for since definitely it has to be in toggle state, we have to give the value of J and the value of K as what? 1 always. That input will not change. Okay, so we should not change, we should not give any other values. So this logic is always 1. Next, this is a negative edge trigger. For first clock pulse we will give a negative edge triggering. Okay, so previously what we have done, we have taken, so the value, okay, so the QA is given as the input, so QB is given as P. Previously we have taken the output from QA, QB, QC, but now we were going to take the output from QC bar, QB bar as well as QA bar. Okay, so that means here you will have the values of QA bar, here you will have QB bar, and here you will have QC bar. So if you observe, previously I have written one table, that is clock, 1 2 3 4 5, like that I have written. So here we have taken, that is what, so q c q b and q a. For the first you have got 0 0 0, so next 0 0 1, next 0 1 0, next you have got 0 1 1, next you have got 1 0 0. Likewise you have got the value. So but now if you observe, so here if you write the values of what, so qc complement, qb complement, qa complement. So what will be the values here? Complements 1 1 1, next it is 1 1 0, next it is 1 0 1, next it is what, 1 0 0, next it is 0 1 1. So likewise up to so up to how many, so that is 8, that is 1 1 1. Okay, the last number will become what, 0 0 0. So that means here we have started with 0 and stopped with 7, but here we are going to start with 7 and we are going to end with what, 0. So this is nothing but what, down counter. Just what we have done, just instead of taking the output from qa qb qc, if you take the output from qa bar qb bar and qc bar, you will get what, you will get down counter. So that is nothing but what, a 3-bit down counter. Okay, so everything is same. So if you want to, so if you have drawn clock pulse for qa, so as like this, so if this is your clock pulse for qa, so what will be the clock pulse for qa bar? So obviously exact opposite to this. Okay, so you please draw exact opposite waveform. I'm not going to draw everything there. So exact opposite waveform you are going to get this. So this is, if this is qa, so wherever you got 0 it will be 1, wherever you got 1 here it will become 0. So that just you draw the exact opposite waveforms for qa bar, qb bar and qc bar if you are going to take like this. Okay, so another circuit is there, but in exam you just try to do this, because this because already you have the waveforms for this circuit diagram, and you are already having the what, so the values of qc qb qa and as well as clock. So therefore by just by complementing the above diagram, a timing diagram, and the complementing these values, you can get directly what, down counter. So you have one more circuit, but for that circuit again we have to do analysis from first. So therefore I will draw that circuit, but I will not do the analysis. Okay, so why means it's a time waste process. So you can take this for what, a 3-bit down counter. Okay, so here what we are going to do, so that means with there is one more circuit also. So if you want to take the output from qa qb and qc only, so if you want to take the outputs from qa qb and qc instead of qa bar qc bar and qc, so if you want to take, then what to do, if you want to get a down counter, instead of giving the clock pulse from qa qb to the next counters, we will give from qa bar. Okay, so this is a second circuit diagram. So that means if you just if you interchange the clock pulse, if you previously what we have done, we have interchanged the output terminals, but here we have not interchanged the output terminals are being changed. We have interchanged the input of clock, that is we have given the complemented value. So obviously if the clock pulse is reversed also, the outputs are going to be changed. So they, again what we have to do, we have to draw the circuit next what, clock pulses, and we have to draw the clock pulse for qb qc. If you draw the clock pulse also, you will get the same diagram, but analysis is somewhat different. Okay, so try to do whichever you feel better you draw that. But I feel that the first diagram which I have given for sorry, which I have drawn for the down counter, better you follow that. Okay. So this is all about what. So up counter, 3-bit up counter and 3-bit down counter. So previously we have seen about timing diagram of counters. So in next we have the last topic of your counters, that is modulus counters, that we will see in the next video. Thank you.